All right, we will work on some ideal gas law problems. Okay? I'm going to... All right. The first one, and notice we have two different R values depending on the units that we're using. We may need to convert some units. So it says, what volume would 3 moles of gas be, neon gas, have at a temperature of 295 Kelvin, we always have to use Kelvin, and a pressure of 645 millimeters of mercury? Well, we can either have kilopascals or atmospheres, so I can actually change this. 1 atmosphere is 760 millimeters of mercury, isn't it? So I could change this, and I may not even want to round anything yet. So I'm going to leave this as 645 over 760 atmospheres. So PV equals nRT. We want to solve for volume, so we'll divide by pressure. So N is 3 moles. Right? R, because I'm in atmospheres, I'm going to use 0.0821 liter atmospheres mole and K. Temperature of 295 K, all divided by this pressure. I'm going to call it 645 over 760 atmospheres. So atmospheres drops out moles, K, and my answer will be in liters, won't it? So let's do the calculations. 3 moles times 0.0821 times 295. And I'm going to divide by this, but I'm going to put it in parentheses, 645 divided by 760. And I will end up, and I believe you need 3 sig figs, 85.6 liters of neon gas. All right, number 2. What volume would be 4.3 moles now of hydrogen gas at 45 degrees C? But we need to convert that into Kelvin, so we add 273, right? 318 Kelvin and 326.2 kPa. 326.2. All right. Well, we'll use the same equation, right? Solving for volume, but now we have 4.3 moles. Our R, we're going to use the other one because we have liters, kPa, mole, and temperature. And temperature is 318. And our pressure that we'll divide by is 326.2 kPa. So notice 2 sig figs, 2 and 4, so I believe our answer should have 2. You can correct me if I'm wrong, but 4.3 times 8.314 times 318, and then I'll divide by 326.2. Now, here's the answer from the calculator, okay? But if we only have 2 sig figs, that would be 35 moles, okay, liters, right? That would be our answer. All right, now how much pressure? So if we have PV equals nRT, we would divide by volume on both sides to get pressure, right? So now we have N equals 4.85 moles, a 4.50 liter tank at 55 degrees C, so let's add 273 to that. So 328 Kelvin, right? Now we have moles, liters. I'm going to go back. I could use either of these, couldn't I? Let's use 0.0821. We're going to use R equals 0.0821 liters, atmospheres, moles, degree K. All right, so pressure will equal N, 4.85 moles, right? R, 0.0821 liters, atmospheres, mole K times our 328 K temperature, and we'll divide this time by the volume they gave us, which was 4.50 liters. So it looks like we should end with 3 sig figs, okay, for our pressure. Now, moles cancels, liters cancels K. So our pressure will come out in atmospheres. 4.85 times 0.0821 times 328 divided by 4.5. Oh, wow. It's a lot of atmospheres. So I'm thinking, I'm going to write this here, but if we have 3 sig figs, wouldn't it be 29.0 atmospheres? That's a lot of atmospheres considering atmospheric pressure is 1 atmosphere. All right, let's look at 4. How many moles? So now they want to solve for N. Could fit in a 475 milliliter bag at negative 22 degrees C and 855 millimeters mercury. Well, we got some conversions because we always want to work in liters. So if we change this, 1,000 milliliters is 1 liter, right? So this turns out to be 0.475 liters. Negative 22 plus the 273 gives us 251 K. And I'm going to change this to atmospheres, which really just would be 855 divided by 760 atmospheres. Because I don't want to round, I'm going to leave it like that for now. So if I have PV equals nRT, I'll divide both sides by RT. So N will equal the pressure, which we have in atmospheres, 855 divided by 760 atmospheres. Volume, 0.475 liters, right? Divided by R, 0.0821 liters, atmospheres, moles, degree K, times my temperature, 251 K. So notice liters, atmospheres were here, K. So this goes on top and we will have moles. 855 divided by 760 times 0.475 divided by 0.0821 divided by 251. And it looks like 3 sig figs. So it's going to come out in moles. I'll just give you a number and then you can decide. Something like this. So 3 sig figs, remember this one doesn't count, so wouldn't it be 0.0259 moles? Okay? Alright, number 5. How many grams? So here, guess what? We're going to have to, once we get moles, calculate from grams. We have volume equals 2.3 liters. Pressure equals 7.5 atmospheres. Temperature equals 24 degrees C, but we need to change that to Kelvin. Add 273, so I get 297 K. And the R with atmospheres and liters was 0.0821. Let's look back real quick. Liters, atmospheres, moles, degrees K. Liters, atmospheres over moles, degrees K. We want to find, so first we have to find moles. So we said PV equals nRT, divide RT. Let's first get moles. So N equals the pressure, the volume, over R, temperature. All right, so 7.5 times 2.3 divided by 0.0821 divided by 297. So it looks like, and I'm going to carry all these for now because, okay, this is how many moles I have. Well, I need to convert from moles to grams. Now, oxygen gas, when they talk about that, that's one of our diatomic molecules. Hofbrinkel, right? It exists as O2. So 1 mole of O2 is actually 32 grams of O2, isn't it? So I'm taking this number, it's already in my calculator, I'm going to multiply by 32. Now, let's see about sig figs. I got 2 sig figs. Well, the number looks like this, 22.63807, blah, blah, blah. 2 sig figs just means 23 grams of O2, doesn't it? If 2 sig figs is correct, but double check that. All right, let's look at 6 now. We want to know N2. Okay, we have a volume of 2 liters soda bottle, a temperature of 23 degrees C. Going to add 273 equals 296 K, and a pressure of 755 millimeters of mercury, which divided by 760 will give us atmospheres, right? So we need molecules, but first we have to get moles. So up there we said moles will be PV over RT. Pressure, 755 over 760 atmospheres. Volume, 2.00 liters. R, 0.0821 liters. Atmospheres, moles, degrees K. And our temperature, 296 K. So liters, atmospheres, K. So we're going to end up with moles. And I'm going to leave it right in my calculator. Again, 755 divided by 760 times the 2 divided by 0.0821 divided by 296. So it gives me a number of moles, something like this, 0.081757766, blah, 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 right? They want to know molecules. Well, we know how to change moles to molecules. Doesn't matter what the gas or the compound is. 1 mole has 6.02 times 10 to the 23rd molecules, doesn't it? So I'm going to take this number in my calculator, times 6.02 times 10 raised to the 23rd, means I'm going to end up with molecules. I'm going to write the number down, then we'll figure out sig figs. 4.9218 times 10 to the 22nd molecules. I bet we can use 3 sig figs there. So 4.92 times 10 to the 22nd molecules. Right, so this is new in terms of PV equals nRT, but it's not new in terms of molecules, moles, and grams, right? All right, what pressure would be needed to fit 35 grams of N2 gas into this flask? So we need a pressure. So right now they're giving us grams. Okay, we have 35.0 grams of N2 gas. We want to change it into moles. And I think 14, I'm looking at my 14.01, so 28.02 grams in 1 mole of N2 gas. And guess what? Because I don't want to round, I'm just going to take this as a fraction and say, here are my moles of N2. All right? And then my volume is 195 milliliters. Well, I have to change that to liters, 0.195 liters. 0 degrees C is 273 K, isn't it? I'm going to stop here and pick up in the next, finish this one up in the next video.